Hello class and welcome to today's lesson on angles and sectors. To start us off, we're going to have a quick review on what angles are and how they started. So for this example, we're going to use this person over here. We'll call them, I don't know, Mr. D. And Mr. D is going to simply be trying to go from point A over here on the left to, and we'll call this point A, to point B on the right. So now I'm going to try and actually get to point B, but what happens is, let's say I get a little bit off the path and I end up at this new area. I'm going to call this point C. So I'm not exactly where I wanted to be. I wanted to be at point B, but I ended up at point C. And what happens is, it's actually all based on this here. So I wanted to make this original path, but I ended up taking this path instead. So we talk about the difference between those 2 points from C and B, that measurement is an angle here. That is all a measurement of an angle. We usually denote this measurement with some sort of Greek letter. We usually use theta here. We can use phi or other ones, but I'll use theta to denote this angle measurement. So angle A, that's another way of saying angle A is equal to theta in this case. Now, some other terms to consider is that the anatomy of an angle, right, to measure an angle, we have to look at the 2 distinct parts, which is, I'm going to highlight this or put an arrow here. Say from A to B, so we call this A to B, this is your initial ray. Initial ray. And from A to C, right, so A to C is equal to your terminal ray. So now let's say now for these rays AB and AC that they are the same distance, aka I was going from point A to point C, assuming I was going point A to point B, and let's say that's 10 feet, and I was like, I'm going to go 10 feet. Oh, I ended here. So if they're the same length, we can say that also they're the same in magnitude. What helps is that now with this measurement, if you were to extend this around and go all the way around, right, we have what we call a circle. So this is representative of these rays of a radius. And we'll denote that by saying this is equal to r, and this is equal to r for radius. Another key piece to note is this information on the right, this part from C to D, this length is actually known as your arc. We usually denote that with s as the variable. And what's very nice about all these variables together, r, s, and theta, they have a great relationship. And I'm going to write that in yellow on the side. Kind of wish I did my colors slightly different. That this ratio is theta is equal to actually the ratio of your arc length, s, over r. Meaning that the angle, if you're looking for any angle, as long as you know the radius and the arc length, you can find that based on the ratio of those two together. Or vice versa. If I were to reorganize this, you can say that this is simply the theta, if you know your angle, times r is equal to s. So knowing that your angle measurement times your radius will give you your arc length. So something to note before we proceed is this idea of what actually theta is. We mentioned it's the variable for measuring an angle, but we haven't said what that measurement really consists of, aka what we measure it in. And below is written theta is measured in degrees or radians. So this idea that as you're moving, right, you're creating this arc length. If you were to go from point B all the way around, that's considered one revolution. So that one revolution, we kind of measure it in terms of revolutions. So degrees we denoted as 360 degrees is equal to one revolution. That's where it's all based on. And then for radians, well, that's based on radial measure. In case of how many radians, aka part of the radius, you go towards moving across one revolution. Now that might sound confusing at first, but let's try to apply it to some problems, and we'll talk about it further in just a moment. So for this example, determine the angle measurement for the following circle. So we have here the radius being 3 and the arc length being 3 as well. So I want you to try to see if you can find the angle measurement for the following circle. So a great way to approach this is remembering our relationship from the last problem, which is to say that theta is going to be this ratio of s, your arc length, to the radius. And in this case, if we plug those in, right, we're going to see that your arc length was 3, and you only need your radius, and I'm going to put this as red, you only need your radius, and you don't need both radii, because the radius is just representative of the distance from the center to the edge of the circle. So that's 3. And if you do this out, this ratio shows that it is a 1-to-1 ratio for this circle. That if you have a radius of 3 and an arc length of 3, your angle measurement is 1. Now, again, we talked about what type of measurements, right? What type of units. In this case, this is 1 radian or 1 rad, because that is rad. Yay! And that's actually why I prefer particularly radians to degrees, is that to me radians make sense as a unit of measurement to, intuitively on if this was 3 meters, right? Let's say this is 3 meters, that was 3 meters, that was 3 meters, the angle would still be 1 radian. It's just the ratio of that arc length to the radius. So before going forward, we're going to have to think about a little bit about our properties of circles and see if we can recall the ideas of, area and distance around a circle. So to do the perimeter around a circle, you remember that to be circumference, which is equal to c is equal to 2 pi r. Pi being a given variable of 3.14 if you round. Okay? And if we go further, we're going to say that the area of a circle is going to be pi r squared. And I'm going to say circle is this going to be, that's going to be my way of trying to say those are denoting a circle. So with those givens, let's try to answer the following. What is the arc length for the sector given? Now, giving you a new word, sector. A sector is referring to what I like to call the pizza pie, or a pizza slice of a pizza pie. So that would be this area here, or that little, let's see. Yeah, that area there. So we need more information to say that, well, what's theta? Theta in this case is going to be 1.2 rad, or radians, and r is simply going to be 10 centimeters. So I want you to try and take a moment and see what you can attempt to do based on the information we were just given, which was that we have here the circumference being 2 pi r. So try and give that a go. Alright, so the first step I would look at is, what is the perimeter? Well, the perimeter is going to be the circumference, which is 2 pi r. But the problem is I don't want all the circumference. I'm actually only looking for this length, s. Now, you could just say, okay, well, what's s equal to? S is equal to that ratio again, right? We had s over r equaling theta. So if we isolate s, well, we have s is equaling to r times theta. That's actually pretty easy to do, right? You're going to end up getting, what is it? In this case, 10 centimeters multiplied by 1.2 rads. And you're going to get 12 centimeters. And that's your arc length. But here's another way to look at it. If I actually knew what my circumference for the whole circle was, right, my whole perimeter, well, the sector, if you look at it in comparison to the whole rest of it, right, it's just a part of it. It's just a fraction of it. So what that means is we can actually say that, hey, what I'm going to do instead is I'm actually going to multiply. So if I'm going to get s, so I'm going to get s from here, I'm actually going to multiply my circumference, my perimeter, by the ratio of, in this case, let's see, s over, sorry, my apologies, not s, theta over 2 pi. Now, just to help you out, 2 pi is one full rotation about a circle. or sorry, about an origin. So in this case here, if I were to plug this in, let's just test this out. Try to call me a liar. 2 pi times the 10 centimeters multiplied by 1.2 rad over 2 pi rad. If you do this out, you'll actually get an answer approximately staying 12 centimeters. Because if you look at it, look at this. This cancels out, that cancels out, and you're left with identically the same thing. But it's another way to reason out how you get 12 centimeters is equal to your arc length. Now I want to try a similar approach to trying to find the area of the sector. So what is the area of the sector? I would very much say give it a chance to think about it the same way we just did, which was, again, if we have a full circle and we know what a full circle's area is, which is simply, let me write this out, again, area is equal to pi r squared. Well, if we have a fraction of it, we can simply multiply by that fraction. It is a part of the whole. So in this case here, I'm going to say, so just to note that your textbook will note an area of the sector with the note of k, so I'm going to put k here. And if the whole area of the circle was pi r squared, a fraction of it would be, again, this idea of theta over 2 pi. And looking at what happens here, I immediately have these pi's, 3.14, canceling out, leaving a simple setup of saying k is equal to 1/2 theta r squared. So let's apply that to our equation. Sorry, to our question. And that's going to give you 1/2 theta is equal to 1.2 rad and 10 centimeters. So that's going to be 150 times 1.2, which gives you 60. And this is centimeters squared because remember it's area. That's the area of the sector. So there you have it. That was an overview of sectors, angles, arc length, all in one. Now there's some details we haven't covered, but we will cover that in another worksheet at a later point. So I hope you enjoyed today's lesson, and let me know if you have any questions. See you next time.